Hello everyone, welcome back. Now here we will see one more previous year question. Now see, the question was like define Castigliano theorem. What is Castigliano? Just tell us in the mathematical form. Or if you are comfortable, then tell us in the actual theoretical language. So see, when we consider a Castigliano theorem, particularly for when a point load are applied, see if P1, P2, P3 dot 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 Pn loads are applied on the beam, and if we are interested and if we want deflection along particular force direction, then along for any force, any load. It may be the actual load or a fictitious load. There is no all are both are possible. Okay, any load. Then it is given as del J is equals to del upon del U Pj. This is the expression where U is the elastic strain energy stored in the body and Pj is the direction along the load. See, Pj is acting. So Pj is the load along which we have to find a deflection. Similarly, it may be written like theta j is equals to del U by del mj. Theta at any specific plane where the moment acting is mj. Okay, so this is about the moment wala case, and then if we say talk about the torsion case, so it would be like this: phi j is equals to du by d dou u by dou tj. It will be like this. And in counter question, they had given one numerical to solve. They had given a cantilever beam, length L, with a UDL of strength W. Let's say this point is A and this point is B. And they wanted us to find delta B and theta B. Okay. So now see, this is the, now I am going to explain you the most important step. Now listen carefully. See, for finding the theta B, there is no load particularly at point B. This is UDL, no doubt, but particularly there should be a load on point B. So we will add a fictitious load, uh, a fake load per se, P over here. Okay, this is a fictitious load. Now we want to write total strain energy. So see, if you explain this much, this is also fine. And if you want to go in more deep, like particularly the equation writing you, it may vary as per the case. Okay, so here we are taking the, this should be the moment wala case. Now mx we will write, that should be equals to minus px. Sign will not matter because sign at the end will, it will be cancelling out with itself. So minus px minus wx square by 2. Okay. Now what we shall do is, instead of going for this, there is a short trick for this. See, del m upon del p we will directly do, which will give us minus x. Okay. Now the next step would be, what was the delta formula? Del u upon del p. Now u we all know, which is m square upon 2 ei into dx. Now, if we differentiate with respect to P and if we go and simplify it, we will get it like this. See, delta is equals to del u, dou u by upon dou P is equals to integration M upon EI into del M upon del P into dx. See, this is a short form. Huh? It will come after simplifying the actual this equation. So you all should remember this one also. But don't go and directly explain this because you should take an example to explain this uh, more properly. So now we would go ahead here. Now see, what was the moment equation? That was, sorry, it was mx equals to minus px minus wx square upon 2. And what we had got del m by del p was equals to, sorry, थोड़ा टेढ़ा हो गया, minus 6. Okay, now as per delta, our formula, it should be 0 to L. Okay, m upon ei na. I will write it here again. M upon ei into del m upon del dm upon dp. What I had written, sorry, del m upon del p. Sorry, p del m upon del p into dx. Okay, now see. When we are putting this m into this equation, I will change color over here. When we are putting this m back into this equation, now since it is a fictitious load, this should be 0. So what will be right now? 0 to delta minus omega x square upon 2 into ei. And 1 second. Okay. Now we have written the m over here. Now del m by del p is, we have found out minus x into dx. Okay. Now see. Now it would be 0 to L omega, sorry, wx cube upon 2 ei into dx. Correct. So 0 to L will now integrate directly. See, b omega x power 4 upon 8 ei from 0 to L. This is omega L power 4 upon 8 ei. So delta we have found out. Okay, quite easy, right? And this method is for some cases much easier than any other methods. Okay, and now, and this is sometimes if you develop an habit in GATE exam also, this is quite much more convenient sometimes. Because the L-shape kind of problems and all those kind of things we have to solve it using the strain energy or this approach. We'll consider some variety on this. Now we have to think for the deflection. Let us consider the cantilever rate again. WL. Now see, what we had seen is was delta is equals to del u by del m. So we have to find a slope at free end, but there is not actually any moment acting. So we'll consider and clockwise moment m acting over here. Okay. So we will do it same. Everything is same over here. At x, we will write mx which is equals to minus m minus wx square upon 2. Now we will do del m x upon del m. That should be minus 1. Okay. Now again, as I told you here, see this. I will use another color to highlight. Here, this method, this. Now it should be theta is equals to 0 to L m upon EI into del m upon del mx, this mx upon del m into dx. Now see, when we will put mx over here, since this is a fictitious m, this should go to 0. Now it will be 0 to L minus omega x square upon 2 EI into minus 1 into dx, which will be 0 to L wx square upon 2 EI dx. On integration, we will get WL cube upon 6 EI. Theta is equals to this. So we have found the slope also and deflection also, and I have explained you the Castigliano theorem over here. This statement is applicable to this also, this one, this one. Here, here. Okay, so I hope you all understood this. Thank you.